Okay guys, so today we're taking a look at properties of line segments. Today we're going to focus on midpoint. So our goal is that I can find the midpoint of a line segment using the coordinates of its endpoints. So the definition for the midpoint of a line segment is the point on the line that is equidistant from the endpoints. So we've got this point here. So that distance is the same as that distance there. And if you think about it, we kind of have two right-angled triangles here. I've got a right-angled triangle here, and this distance is 4, this distance is 3, and if I use Pythagorean theorem, I'd find that that distance there on the hypotenuse is 5. And if I did the same thing here, that's 4 and that's 3. So that also has a distance of 5. So obviously that is the midpoint of that line segment. But let's take a look at how the coordinates of the points work here. So the coordinates of this endpoint is 1, 2. And at the other end, I've got 5, 6, 7, 8, 9. So that is the point 9, 8. So let's just take a look at the x coordinates to start with. The midpoint, if we do the coordinates of that midpoint actually, that's going to be 5 and 5. So let's see how that works out. So for the x coordinates, I've got 9 and I've got 1, and the midpoint ends up being 5 for those. And when I look at the y coordinates are 8 and 2, and the midpoint, the y value, is 5. Well, watch what happens here. If I add these two coordinates from the endpoint together and I divide that by 2, I get the midpoint value. And if I add the 8 and the 2, the y values from the two endpoints, and I divide those by 2, I get that midpoint of 5. Basically what I want you to take away from this is that when you're trying to find the coordinates of the midpoint of a line segment, the midpoint is the average of the endpoints. And think about that. If you want to find the midpoint of any two things, it's the same as finding the average. So you're adding them together and dividing by 2. So that's where this formula comes from. We add the x's together and we divide by 2. We add the y's together and we divide by 2, and that gives us our midpoint. So let's see how that works when we do some questions that involve midpoint. So here we've got a couple of endpoints here. So I'm going to plot them on the graph. So I've got a point at 4, 9, 5, 6, 7, 8, 9. So I have a point there. And I've got a point at 2, -1. So I've got a point that is right there. So I want to try and find the midpoint of this line here. Let me just straighten that guy out a little bit. So let's go on to there. Just move this guy over a little bit. Yeah, that's pretty good there. Okay, so we're trying to find the midpoint of that particular line. Now, if we use the formula that we just talked about, so we average the x's, so we add the two x's together and divide by 2. We average the y's, so we add the y's together and divide by 2. So if I plug in my x and y values here, the x's are 4 and 2, so 4 plus 2 divided by 2, and the y values are 9, and minus 1. And I'm going to divide that by 2. So when I calculate it, 4 plus 2 is 6, divided by 2 is 3. 9 minus 1 is 8, divided by 2 is 4. So let's see if in fact the point 34 is the midpoint on our line in our graph. So I go to 3 and I count up 1, 2, 3, 4. And there is the midpoint at 3, 4. Example 2. The diameter of a circle has endpoint 4, 3, and negative 2, 6. What is its center? So the center of a circle is the midpoint of the diameter. So remember working, I'm sure in math you've worked with diameters of circles before. They go from one side of the circle all the way to the other side of the circle, and they go through the center, and that center is the midpoint of that diameter. So we need to find the midpoint of these 2 points. So same thing, we're going to use our formula. So I'm going to be doing 4 minus 2 divided by 2, and then the y values, I'm going to do 3 plus 6 divided by 2. And so when I calculate this, 4 minus 2 is 2, divided by 2 is 1, 3 plus 6 is 9, and 9 divided by 2 is going to give me 4.5. So therefore, the center of the circle is at 4.5. All right, one more example here. In this one, we kind of have to work backwards, because in this one, they give us the midpoint. They say the midpoint is 3, negative 2, and they give us one of the endpoints, which is 8 and 15. Let's start by writing the formula down. So there's our formula, and we're going to plug in what we know. Now this time we know the midpoint. So the midpoint is 3, negative 2. So that goes in for the m. And then we know one of the x values. So one of the x values is 8, but we don't know the second x value. One of the y values is 15, but we don't know the second y value. Okay, so it looks a little messy there, but at this point what we're going to do is we're going to do each coordinate separately. So I'm actually going to work with the x's together. So here's what I know. I know that 8 plus the second x divided by 2 has to equal 3. So if I multiply both sides here by 2 to get rid of the fraction, these 2's are gone. So I'm left with 8 plus that second x equals 6. When I take the 8 to the other side and subtract it, I get negative 2 is the x value. Now I'm going to do the same thing, but I'm going to do it with the y part. So now it's going to look like 15 plus y2 over 2 equals negative 2. Same thing here. I'll multiply both sides by 2. The 2's will divide each other on the left side here. So I'm left with 15 plus the second y value equals negative 4. And when I move that 15 to the other side and subtract it, I get y equals negative 19. So therefore, the other endpoint is -2, -19. We're going to practice some of these questions tomorrow in class. Thanks.